that we had with it. Thanks. I'll watch my words now. All right, so there are a lot more details on this that I can refer you also to the chair paper and some of the slides on this. But what we kind of did is take these sort of framework, this liberal model, the critical model, and these sort of things, and actually see if we can translate at least some parts of these standpoints to metrics. So that's what we did in our tiers paper. So we have some of these things worked out. So we have calibration, that's how much we tailor to user preferences, for example. We have fragmentation, like how much do we specialize what we recommend to a user, how much we activate them, how present alternative voices are. These kind of things is what we try to do in these metrics. I won't show you all of these metrics. Let me show you one at least, so that you have an idea what's in some of the slides as well. So we have what we want to measure, the kind of context, and then we have sort of an expected range of whether these things actually differ with each other and how we can actually operationalize them in a production setting. So what you get then is that we have, for these different models, we actually have different standpoints on what metric we want to optimize for, and that corresponds to a democratic theory of how we want to do recommendations there. Of course, there are a lot of limitations here still. So it's very much an oversimplification, and there's bias here. But it's a step to. Sanne put it on the slide as constructive oversimplification. So we want to have the discussion and try at least something that we can test out. To get that discussion going and see what other things we could take and build that bridge from the democratic theory towards the kind of things that we actually optimize for in a recommender system. I think with that, I'll end it looking at the clock as well. And I think we do have time for some questions, but I'm looking at the organizers for that. 5 minutes for questions. Any questions online already? Then I'll give it to the floor here. Yeah, Alain?
So with regard to, let's say, the last part, when you think about designing metrics for such things, would you then find it more important what you can sort of objectively measure as a producer of these recommendations? Or would it be more important, that users can sort of notice that they are, for example, being heard, or that, let's say, minorities feel represented by the algorithm?
Okay, so I need to repeat the question because we don't have a mic for the online audience. But if I can summarize, you're wondering sort of what perspective is more important, of the producer of the recommendations or of the consumer, and where is to meet. Yeah, so I think the theory helps us to actually align this a bit more. If you can think about it on sort of high level, like what kind of recommendations do we want to have? We are closer to what we want to show to a user. So I think it helps us actually there to make that connection. I think the thing that I can influence with the team is what recommendations we serve out to users. And I think there's an important aspect also of that, of explaining it to the user, of showing why we do things. But that's really difficult to do in a good way. So previous at Blender, we did do some experiments with this, was kind of interesting. We gave explanations for recommendations that we showed on news personalization there. What we saw actually is that users said they really liked the feature, they wanted to have it absolutely when we did user studies, but in practice we saw no effect of this on click-through rates, on customer loyalty of any kind of metrics. So I think it's something that people like to think that they have, but I think in reality that's not directly what they're using. Yeah. Do we have a question online to diversify a bit? Okay, I think Marijn was next.
Yeah. Table with all the different goals and missions. Nice thing about these sort of holistic thinking from theory that you have multiple dimensional aspects. You can start thinking about how can I measure certain things. But you can only sort of figure out one thing to measure. Does it make sense that you know you're missing out on all the other dimensions? Or you create a new scheme to apply.
Yeah. Okay. So I think the question is sort of like, we have a lot of multidimensional things that we can measure with this work. But if you can only optimize or measure one, then you need to pick and what do you want to optimize for. So I think that table does help in thinking of what kind of things are important, like which things should you measure. I think in the end, when you're building a model, you can only optimize for one objective. You can sort of combine things and weigh them and then make sort of a combination. But in the end, there are a lot of choices that you're making there. So I think the theory helps there to measure at least something that you think is important. I think you should also always look at more than one metric and check it. So if we're comparing our production system with a new system, we would definitely look at more than one metric to make a final decision. So if we do see that we see way higher click-through rates, but we have a way worse representation of alternative voices. If we're actually able to measure all these things, then that could be a reason not to go to production with a model like this. So I think it helps anyway to have multiple measures there. Yeah. Yeah, so in the chair paper we have a first step of the operationalizing these metrics from the table to how can you actually measure them, and we're now actually working on a paper, so that's directly with the team from the University of Amsterdam and the data scientists at RTL on operationalizing this and actually testing it on the Mind dataset, so a big news recommendation dataset. So we're submitting that somewhere soon, but I cannot show the results yet. I think there was a question there. Yep. Kim?
Just to comment on what you're talking about, maybe you could make that table actually into embeddings, and then you could measure similarities to those embeddings, and then push it towards each of those points. I don't know if that would work.
Yeah, I can imagine. So see it more as I guess this table as see it more as softer targets rather than hard targets. Yeah, and then maybe make a combination of this. I can imagine that it could work. Yeah. Okay.
How do you want to personalize trailers? I know that that's not really the more important thing, but just curious.
Well, so what we do now is so the examples I showed are so-called ident, so they're really short kind of trailers that are sort of the easiest step for us to ease into. We do generate a lot of other trailers, so for programs, but also monthly trailers of new things coming up on our platform, these kind of things. And especially with this last one, it's very clear that if I know what you've watched on our platform, I would definitely put in different new content or change the order or highlight different parts, spend more time there. And that's something that our promo editors cannot do. They cannot generate 30 different trailers and show them to different people. But it's something that we can do if we're able to approach their level and support them. So I think that's something that we can do there. Also highlighting different people. We know from Netflix as well that the kind of stills that you see on their platform, they are personalized for you. They highlight different actors depending on what you've watched and these sort of things. And you can do the same thing in a trailer, right? Yeah. Cool. Anything online? Okay. Oh, yeah, sorry. Yeah, there's a strong light here. Yeah. Yeah, so the plot of sort of showing the universe of our recommendations. So Matteo generated this. He's around at the conference, so you can talk to him a bit more about it. So I think on the links there, so it's using the connections between different articles, and for the TF-IDF based one, for example, we used only the 15% strongest connections there. And I think he used GraphViz for this, but I have to double check with him how he generated the plots. But if you grab my arm somewhere later in the conference, I can show you how we do it. How we use it actually in practice. So I think it helps us to sort of understand what's happening and to diagnose sort of how we are doing things. And it helps explain how we build our recommendations. In day-to-day, how we build our recommender systems, this is sort of just a step of checking what we do. I think one of the things that we also do is sort of check up on our own recommendations as well, like what do we get and can we understand why this is happening? And this is another tool for supporting that and figuring out what's happening with our recommendations. Yeah. All right. Thanks.
Okay, thank you. So our next presenter will present online. Yes, sorry about this. Okay, so our next presentation will be by okay, so it's the paper How to Effectively Identify and Communicate Person Targeting Media Bias in Daily News Consumption by Felix Hamburg, Timo Spinde, Kim Heinzer, Karsten Dunay, and Bella Gibb. So it will be presented by Kim, but
Hi. I don't know if it's working.
we can, yes, now we can see your presentation, I think. Okay, Kim, we can't really see it right now here. They are trying to adjust it.
Can you hear me though?
Yes, we can hear you.
Perfect. Okay. First step. I will share my screen. Can you see my screen now?
No, not, well, I can see it through the Zoom, but we can't see it here on the big screen.
All right.
So if you can connect my computer, maybe I can just put it out there. Okay. Yeah, sorry for keeping you. Okay, I think we got it for a moment. Sorry? Okay. Okay, now we see it as well.
Great. Okay, 1 second.
So I guess this is this my screen we are seeing? Okay. Okay, great. But we are seeing your presentation now, Kim.
Good. Okay, then I can start.
Yes.
Okay, perfect. Yeah, thank you for having me. This is actually my first presentation at a conference like this or at a workshop. So thank you very much. I am presenting today our short paper on how to communicate bias, specifically person targeting bias in daily news consumption. So just a brief outline, what I'm going to talk to you about. I'm just going to show you a little bit our workflow, the visualizations we employed to communicate bias, how we evaluated our system, a little bit of a critical discussion of our results and what we're going to do in the future. So the general question that we asked ourselves was, how can we communicate bias to non-expert news consumers? So the idea here is just overall making navigating through the news space a little easier with the prevalence of biased information, of articles trying to influence readers. And the focus here is not to prevent bias. So the idea is not that bias is something that we can just erase, but the idea is more to mitigate it. So to make it visible and then to give consumers better choices and a more well-rounded opinion. And there's been methods before to employ this, but most of them have been manual. So it was manual annotation of an article, for example, of bias sentences and certain styles that indicated bias. So this, of course, is very costly. The results often were more superficial, so there were very sophisticated IT approaches behind it, but the actual analysis of whether these approaches have an impact on consumers, so a more social science, psychology approach has been lacking. And a big topic also in previous research was that the focus was more on visibility rather than presence of bias. So what this means is often we would use an article's political slant. So we would say the outlet of this article is left oriented, and thus we label this article as left, and we make this bias visible. However, even an outlet that is more left focused could have certain articles that have more center content or even right-wing content. And sometimes the methods previously used were more focusing on making this visible rather than is there actual bias presence in this article. So this is where our system comes into place. The input is, of course, news articles, and the output is a grouping into perspectives. And the idea is through employing cross-document co-reference resolution to have different groups of articles that portray a topic in a similar fashion. We have different methods, and it highly depends on the method, of course, how the grouping is derived. in this paper, we're going to focus on the most frequent actor polarity method, which first identifies the main actor. So we could have, for example, we had various topics. One topic was the bushfires in Australia in 2020. And the method would first identify the main actor, which in this case was Prime Minister Morrison. And then secondly, would group the articles according to how the sentiment is about the actor. So here's an example. First, you can see on the top, the most representative article. And then we have a 3-group layout. So we have articles that are rather positive about a person, articles that are rather negative, and then in the middle, ambivalent. And it's important to note that in this case, ambivalent does not mean neutral. It just means that, for example, there would be the same range of or a rate of positive and negative sentences about a person. And then additionally, we also have tags. So you can also see there are tags center, center, left. So these articles are also tagged along their outlet's political slant. We also have an article view. So after seeing this broad overview of articles on a topic, we can also see within one article, so respondents get a randomly selected article, and then they can see at a first glance, is this article rather positive or negative about a person? And they can really see in the sentence and get a greater awareness that this sentence has some sentiment about a person. We also have a polarity context bar. So we also show how the article is compared to other articles. So not just grouping, but also showing how extreme an article is compared to other articles. Now we were trying, or we tested these methods on a large sample with over 300 respondents, and they also performed various tasks. So we managed to generate a lot of data through this process, and we employed the study on mTurk, and we operationalized bias awareness through 2 questionnaires that focus on the presence of bias. So do respondents actually see that bias is present in articles compared to a baseline where we don't show them any indicators? So we have the bias agnostic baseline, it's called plain, which just means it's just a list of articles without any grouping, without any further information about the political slant. Then we tested in different variations our method, so the most frequent actor method, and then political sites, which is the more common method used to just group articles into their outlet's political slant. And then additionally, we also tested, is there an effect, for example, if we group an article according to their most frequent actor polarity, if we additionally also show the political side, does that make a difference as well? And in the article view, we tested different color schemes of in-text highlights. So if we show 3 colors for positive, negative, neutral, or just 2 colors, positive, negative, or we just show sentiment without indicating whether it's positive or negative, and the polarity context bar. And then we additionally also show the bias groups for the individual article. Now, to actually, without confounding, measure the effect of each of these attributes, we used a conjoint design. I think due to time reasons, I won't go into detail on this, but the idea is that we can randomly vary all these different attributes and then see a relative influence and really see which influence each attribute has. So what we found was within the overview that all bias sensitive overviews had significant positive effects. The strongest effects were still by showing the political slant outlet, and on top also not just grouping them, but also showing tags for all other articles that were not grouped. And second of all, we also had a strong effect by our method. it was interesting that the strongest performing method was actually our method, so the most frequent actor polarity, without any additional tags, so not indicating any political slant. We also had a weak effect of a random grouping, where we just, we had the layout, but it pretty much the grouping had no meaning. It's just completely random. We still had an effect on bias awareness, which is also interesting in the future. So yeah, just as a discussion of our result, the idea was when we also looked at qualitative statements by respondents, we also asked them qualitative questions. It did seem like our method reveals biases that are present in the articles where respondents say this resonates, this makes sense, whereas the political sides, it really just shows general direction. What we also saw, as I mentioned in the previous slide, that the most frequent actor polarity method was most effective if there were no additional text, which could be due to the fact that respondents don't really know this type of grouping yet. Everyone knows, of course, left, center, right, but this idea of grouping articles into their polarity is not as prevalent yet. And then what was also interesting, just putting tags on articles without grouping them into perspectives didn't have an effect. So we could see that this bias group layout might be necessary to facilitate bias awareness as well. Then I think due to time constraints, generally we didn't find many results or on the article view, there were not many effects. We attribute this to probably there were too few in-text highlights. We had quite a few articles where there were very few highlights because the most frequent actor of this topic wasn't actually mentioned in the article. Then, of course, an individual article is just very hard to compare to other articles. We also didn't have enough of a sample size for this variety of articles. And we also thought that expanding the entity, so not just looking at an actor, at a person, but also how does the article portray political groups, places, religious affiliations, and so forth. As a general discussion, our main goal would be not just to increase bias awareness, but to actually capture frames, which already looks very promising, but of course this needs more and further investigation. And a big limitation of the study is that the study design, of course, is not completely realistic to how news are actually consumed, because we give respondents an article and they didn't choose the article. But for this study, at least, it was the best option to make sure that we can measure the effect without any confounding variables. And lastly, as future implications, we already did this. We revised our questionnaires. So instead of just asking respondents whether they can see bias, the idea would be to move more to critical thinking and also the term of online civic reasoning. Then, which would be also really interesting because the random version also had an effect to separate the grouping from the explanations. So to test whether just saying this article is left or right or center already has an effect, even if that's not the case. And yeah, lastly, just a general question, is it possible to visualize bias, not just in an overview, but also in an article view? Because to us, bias is inherently comparative. So can it actually be visualized within one article alone? And that's it. Feel free to ask any questions.
Yes, thank you, Kim. Are there any questions from the room here? Or if there are any online questions, maybe you can unmute and ask, or you can use the chat window. Okay, I don't see any questions from here. And also due to some technical problems, we are behind our schedule. So maybe it's time for a break then. Thanks a lot, Kim, again. And I will post the WonderMe link for the virtual attendees on the Zoom chat. And for other people, we will meet here back in like 10 minutes. Thank you.
And that's today's talk is about whether our news retrieval algorithms resonate with what a user judges two articles to be similar. So this talk, I will show that if you predict inter-article similarity for the political news domain, it can be predicted at the feature level. So not as an article as a whole, but at the feature level. And that some features, for example, the body text of these political news articles, that they are more representative of human similarity judgments, while others poorly represent them. And finally, similarity functions in news seem to be less representative for human judgments than in some other domains. And in this study, we looked into the domains of movies and recipes. So this is how we approached the news recommendation problem. Here is a Norwegian news article, and you can break that down into different parts. So there is a main image, a title, a lead paragraph, date of publication, the main body text, maybe a few tags and categories. And each of these are features of a news article that you can leverage to come up with new recommendations. Typically, what you see is that there is a similar item recommendation that, based on, let's say, the overall similarity, or typically on recency, news articles are recommended. And there are a few research gaps that we identified in this respect. So quite a few news recommenders do this overall and not really feature-based. And what is computed might not really reflect what a user thinks about whether two news articles are in fact similar or not. And while specific features, if you use them to predict whether two news articles are similar, may be quite representative, others might not be. And a lot of algorithms that we see, or recommendation approach that we see at the venue, they might have a different goal in mind. For example, to optimize engagement, or Netflix might be more interested about whether you watch a movie and doesn't really care about which specific movie. Whereas a news recommendation, you might care a bit more about what a user does with it. And therefore, one algorithm from one domain might not really be representative in the current domain. So in this study, we're going to compare some of the outcomes with findings from another paper in the food and movie domain, where they also used feature-based similarity functions. So for the occasion, I picked a very Dutch recipe, boerenkool met worst en spekjes. I'm not sure if you'll be able to find it right now because it's a bit of a winter dish, but it's like a mashed potato with kale. And you can also identify a number of features here, just like with the news article. So there's a title, an image, directions to prepare the recipe. There are a few ingredients and a few categories. So these are sort of different entities that you can leverage for recommendation. So in the study of Christoph Trautner and Dietmar Jannach, they were learning to recommend similar items using human judgments. So they were checking whether, when they presented two news articles and they computed two recipes, and they computed how similar they were, whether users also perceived that. So here you can also identify the title, image, ingredients, and directions. And then they correlated the overall user judgment of similarity with similarity functions that were specific for different features. And there, for example, they found that in recipes, titles were rather representative of a user judgment, whereas images were less so. So in our approach, we take this to the news domain, and we want to develop similarity functions that are feature-based. And for the occasion, we have just sort of taken the functions that were used in those other domains and applied them to news with a few tweaks and a few adjustments that I will show in a minute. Furthermore, we thus example to what extent these functions represent user similarity judgments. So which features predict user similarity judgments, which of these cues are actually considered, And how do these results relate to findings from the other domains? So for our study, we performed a online user study. We took a data set from the Washington Post corpus. So that's news articles from the Washington Post, and we focused on articles that were sort of categorized as politics, because they had a more, let's say, nationwide recognition. So a lot of quite a few articles in the Washington Post would be about sports teams, and that people from the, let's say, the Washington DC area would be able to recognize them, but not people from, let's say, the West Coast of the United States. And we sampled 2,400 news articles for our user study after performing some feature engineering. These were the feature-specific similarity functions. All the details are in the paper, but we had title functions. At the top you can see something based on a subcategory of a news article. We engineered the sort of the low-level image features, so brightness, sharpness, contrast, colorfulness, entropy, and image embeddings. We checked the date, we checked who wrote the news article. We had text features where we differentiated between the entire body text of a news article, but also the first 50 words, because perhaps people might stop reading at some point, and sentiment analysis and an author's biography. So for our user study, we designed a task that was quite similar to the other study in the recipe and the movie domain. So we presented 2 news articles up on the screen, and we asked our participants, to what extent do you think that these 2 are similar on a 5-point scale? On top of that, we asked, how confident are you in your judgment, and how familiar are these news articles to you? So users need to do this 10 times. We used 9 observations, because 1 was dubbed as an attention check. And they also disclosed demographics, frequency of use for online newspapers, and to what extent they use different cues when making these judgments. So we had 401 of Amazon MTurk, and sometimes you can deceive them a little bit. So we lost 160 based on our attention check. I will show a few results of, let's say, the entire group versus the group that only passes the attention check, because it was quite a big chunk that did not spot that I needed to mark rating 3 in one of the tasks. So the results. There are 3 different things that I'll show. First, the self-reported cue use. So on the x-axis, you can see, if you tilt your head a little bit, subcategory, title, image, author, date of publication, and body text. And what stands out is that people report to use the title of a news article and the body text mostly for the similarity judgments. So based on that, you would also expect that similarity functions on those features would be most representative. We tested we did some pairwise similarity, or we did some pairwise tests whether these differences were significant, and most of them were, but that's not the main takeaway here. Here's perhaps a descriptive plot that tells you a bit more. So in, let's say, the dark purple, you can see what the similarity scores were for the overall similarity functions versus the user judgments. And you can see that participants had a, let's say, relatively hard time in judging, or, well, they didn't really see a lot of similar news articles in their perception, because the scores were quite low, and you can already see there is a bit of a disconnect here. So we didn't expect quite high scores, and perhaps that it was a bit hard to judge whether 2 news articles are similar. So we performed a correlational analysis for different features. So we compared the overall similarity judgment of a user for a news article pair against what the similarity function would compute. And what you can see here is that body text in full, that was among all those features the most representative one, as in that it had the highest correlation with the user judgments.
few other features that performed okay, or similarity functions were using image embeddings or the author biography. But what you can also note is that even though a lot of, let's say, users indicated to use the title in their similarity judgments, these correlations that you can see over there, are really small. I mean, some are significant, but 5, 6, 7%, that's very minimal. So they didn't seem too related. When we would compare results from a similar task in the recipe and movie domains, there are a lot of numbers on the screen, but I'll take you through it. So for recipes, you can see that titles and directions were quite representative, with correlations up to 50%, which is much higher than any of the values we found in news. In movies, you can see that a genre-based similarity function or more a recency or a plot-based were more representative and also yielded higher values. So it seems that, let's say, using this approach, or at least taking it from those domain into the news domain, they didn't have the same result of representativeness in terms of user judgments. Finally, we did a model-based comparison in the sense that we tried to predict a model based on all features. We inferred a root mean square error and an R squared. The outcome was a bit lower than in the other domains, and we could also confirm this way that using body text was the most representative to predict our data here, to model our data. On top of this, we tried to implement an additional number of user characteristics. They didn't really increase the model performance that much. What you did see is that similarity judgments were a little bit higher if people were familiar with news articles, which I guess makes sense. If you think about, if you need to judge something and it is familiar, you might have more knowledge about it, and you might be more likely to give a higher score. So that's what I wanted to tell you. So let's summarize the main takeaways. So text-based similarity was found to be the most representative for user similarity judgments in news. We think it's in part because users gave low similarity scores on average. And it seems a bit hard to tell for a user, what makes two news articles quite similar. So I think a lot of approaches have always focused on recency, but we didn't find, let's say, much evidence that the date of the news article was important here. One, let's say, disclaimer there is that we sampled with quite a broad bedwind, so we didn't really have a lot of pairs that were published on the same date. We have title-based similarity functions, to our surprise, and also to the surprise of, let's say, the user self-reports. They didn't really represent. The similarity functions there didn't really represent the user judgments. And we have only now used one data set and one category, so we can do a bit better than that. And also the similarity judgment that we asked for is just on a scale from 1 to 5 with overall similarity. So that's not, let's say, very detailed if you're investigating feature-based similarity. So we should do a bit better than that. So we will continue our work by addressing these points, and also addressing user evaluation metrics, so that we're not only computing similarity in terms of representativeness, but also what a user would think of a news article pair, or what they would think of a recommendation, if it's more, let's say, a recommender system context. That's it. I got some support from Media Futures to make this happen, and questions are more than welcome, and here's how you can contact me and or follow all my tweeting. So thanks. Yeah.
So I understand that you want to explore different similarity function how that works, but do you have a specific task in mind? Is this a recommendation task down the line?
So the question is, I was exploring similarity functions here, but is there a specific recommendation task in down the line? So let's say one of the, the bigger tasks that we would have is that you could focus on specific features that would be more representative for user judgments, so that you might, let's say, discount the ones that are less representative of these similarity judgments. That the thought was that it would, in the long run, lead to higher levels of user satisfaction. So one of these studies that I cited on the very last slide from Zhao and Harper, they showed that user similarity judgments, if two things were more similar, then a user's level of satisfaction would also be higher. So that was sort of, if we could now find which features are the most important or most representative, that we could maybe, let's say, increase satisfaction of the users when we would use that in a recommendation scenario compared to, let's say, using less representative features. Yeah.
I wonder, taking out from one, but I wonder how much similar your articles were in general. I understand it's difficult to quantify, but since they were sampled from quite a long time period, I imagine that probably would not be so many like articles about one specific event, like a follow-ups, and those are the ones which I would probably expect to be really similar and also judged as similar by users. In the data set?
Yeah, so the question was that normally in a recommendation scenario you would have articles that are really about the same news event, and the question was whether that was present in the data set. Yeah, we could check this a bit by checking, for example, well, recency would be a proxy for that. And I think that there were a few pairs that were, let's say, quite close, but there were also quite a few pairs that were indeed, let's say, 2 years apart or 2 years apart. We can't really trace back that well whether it was about the same news event. So that's, I would say, a limitation in terms of what a lot of people use, let's say, recency-based news recommendation for. Yeah, so that's a bit missing in this study. No.
They have a challenge in the topic of ECM. So, what is that the methods that perform the best for a recommendation path, where you see declaring user strat, the data getting from title, the abstract, without any teaching you. So, what would you say that this kind of exploration that is more handcrafted feature would have an advantage over this zero-graph method?
So the question is whether, let's say, handcrafted features have an advantage over deep learning, given that there was a challenge with a news data set from Mind that showed that performed better. I think when it comes to understanding what's going on, then I guess that crafting features might be very useful. If you're perhaps just optimizing, let's say, for the pure accuracy, then I guess that deep learning, or let's say the more latent feature engineering, that might also be a very good approach. And I'm thinking a bit about design implications here for if I would do a similar study, but I would have to come back to you about that. Yeah. Okay, I see some gestures that is done, so thank you for the questions, and see you around.
Okay, I think we see the slides. The next talk will be presented virtually by Fatih Gedikli. I'm sorry for mispronouncing that. And he will be talking about news story chains. So Fatih, you have the word.
So hello everyone, and welcome to my talk about semi-automated identification of news story chains, a new data set, and entity-based labeling method. So in news analytics, there are different degrees or levels of abstraction. On the one hand, you have individual news articles, and on the other hand, you have news topics or latent news topics such as business or sports. And between these two levels of abstraction, you have follow-up news and news story chains. What is a follow-up news article? A follow-up news article talks about the same aspects like an earlier article, but provides more details and also comes from the same news outlet. And then you have news story chains. In this talk, we will focus on news story chains. And what is a news story chain? We define a news story chain according to the literature. So a story chain is a collection of news articles that report on the same event. So the event is central for us, and an event might be a plane crash, for example, or an earthquake somewhere in the world. And the articles in the story chain describe different angles of the same event and may also come from different news outlets. So in this work, we focus we follow a data-driven approach or a data-centric approach, and so instead of asking ourselves how to create a machine learning model based on other machine learning models to tackle the problem of news story chain detection, we focus on the ingredients, so on the data. So the question is how to build a better data set for news story chain detection. And what are the data-related challenges when dealing with the problem of news story chain detection? First, the data sets are sparse. As usual, news story chains are to some extent underrepresented, and there are only a few positive examples, usually in a data set, positive examples for related news articles. And you also don't have a time bound. So the related articles can be released months or even years later. And you also have a quadratic coding or labeling effort, because you have to compare each news article with all other news articles. And so there is a lack of methods to automate the process of labeling pairs. And therefore, we present a semi-automated entity-based labeling method in this work. So next, I will show you our article selection procedure for constructing a novel news story chain data set. And as you can see here, our article selection procedure gets as input a list of news articles and returns as output a list of n selected news articles. And this is a cluster-based approach, and we use the named entity shared measure from the literature to compute the similarity between two articles. And after we get the n-selected news articles, we generate all pairwise comparisons of the articles. And if an article pair has no common named entity, then the article is automatically labeled as unrelated. I have forgotten to say that we only focus on the entity types as named entity types, person, location, and organization, because these entity types can describe an event very well. So if an article pair has no common named entity, then we automatically label this article pair as unrelated. And if an article pair shares at least one common named entity, then this article pair can be related or unrelated. And in this case, we have to examine the article pair manually. And we tested our approach on two different data sets, and we found that 80% of the article pairs can be automatically labeled as unrelated. And this reduces the manual labeling effort drastically. So here you can see the two different data sets we used for evaluation. On the one hand, you have the business energy news data set where we publish with this work, and which was also built according to our procedure. consists of 100 news articles and 4,950 article pairs, and focused on business energy news. And on the other hand, we tested our approach also on unseen news on another data set from Nichols and Bright. This data set contains articles for the public, for example, from BBC News and so on, and contains 254 news articles. So here you can see that the number of article pairs that have to be manually examined or labeled can be reduced by more than 80% for each data set. So to evaluate the usefulness of our approach, we gave two human coders slightly different tasks. So coder 1 worked with the assumption that only articles that share at least one named entity are candidates to be part of a story chain, so they can be related or unrelated. And the coder 1 only focused on these 901 article pairs and labeled them manually. So the rest, so more than 4,000 article pairs were automatically considered unrelated. And coder 2 was tasked to label all article pairs as being related or unrelated, and was only informed about the concept of a story chain, but was not made aware of the background of our study and the goals of the study. So coder 2 labeled everything. So this confusion matrix shows the results, and the numbers in bold are the number of article pairs where both coders agreed. The non-bold numbers are the article pairs where both coders disagreed, and the numbers in parentheses are the number of article pairs which were automatically labeled as unrelated by coder 1. And as you can see here, there were only 27 article pairs where both coders disagreed, and in more than 99% of the cases, both coders agreed. So our method based on the co-occurrence of named entities is highly effective in terms of identifying pairs that are not part of a story chain. And the coders agreed in more than 99.4% of the cases. So this leads to an Krippendorff's alpha of 0.87, which indicates a very high inter-rater reliability. And the coders only disagreed on 27 article pairs. We further analyzed these article pairs, and the difference was caused by the misclassifications by coder 2. And the detailed description can be found in the online appendix. So we also tested our approach on the data set from Nichols and Bright, and in order to test our approach on unseen news from other domains, not only business domains. And we only found 3 false negatives. That means that there were only 3 article pairs which were incorrectly flagged as unrelated because they had no common named entity. And these article pairs had all in common that they contained video content. And the corresponding article text files provided by Nichols and Bright, they were empty. So we couldn't compute any named entities from the article text files. So if you ignore the video content, articles with video content, then you can reduce the coding effort, the labeling effort by more than 80% without loss of precision, without any error. And our final data set we published with this work, the business energy news data set, is less sparse than the one by Nichols and Bright. It contains 4.5 times more positive examples for story chains. So what are the take-home messages from our study? Our data collection procedure reduces the manual labeling effort by more than 80%, while the quality of the data remains the same. And our article selection procedure can also increase the number of positive examples for new story chains in the data set. And we also publish our data set of business energy news online. In future, we want to go beyond named entity recognition. So currently we are just comparing strings, named entity strings. And in future, we want to use named entity disambiguation in order to map these strings to real world entities from a knowledge base such as Wikidata in order to deal with synonyms. So we want to go from an exact entity search to a more flexible semantic search. So we can deal also with synonyms, for example. And you can also use news story chain detection for detecting fake news. For example, you can identify a news story chain and try to identify outliers in this chain. This could be an indicator for fake news in a news story chain. For example, if everyone is talking about the same facts and only one or two articles are talking about the same event, but adding more additional facts, then this could be an indication for fake news. So thank you very much. And if you have any questions, let me know.
Also, we don't appear to have questions in the room at the moment. Let me check the online chat. So there are also no questions. Anyone curious about story chains? Okay, if there are no questions, then we almost made up for the technical problems that we had in the last session. So we can take a short break, I think, at... Okay, that's a good idea. So for this workshop, we also created a Slack channel in the RecSys Slack. So if you want to join and stay in touch with us, then that would be the place. We will have a short break now until 11:40. The WonderMe will be active again for the virtual participants. So we encourage you to engage and mingle there. And we will be back with another session at 11:40.
Can the online participants hear me? Okay, great. So we will start with our next paper presentation session. And the first presentation is interactive visualization of the polarity-based stance of news websites using news genres. And Masaharu Yoshioka will present this paper. So just to avoid the technical difficulties, I'm going to play a pre-recorded video, but he is available online on Zoom. So if you have any questions, you can also write on the chat, and he will be available to answer the questions afterwards.
I'm Masaharu Yoshioka from Hokkaido University. Today, we would like to introduce our research titled Interactive Visualization of the Polarity-Based Stance of News Websites Using News Genre. Recently, we can access varieties of news sites via news aggregation sites. As a result, we can read news articles from the news sites that are not well known. However, since each news site has its characteristic for reporting news, it is preferable to understand its characteristics for appropriate understanding the contents. For this task, we have proposed a framework that helps to identify potential bias in news websites. For example, since most of users know characteristics of CNN and Fox, if we can plot the news sites by using such bias, it is helpful to understand the characteristics of the news sites. In this research, we proposed polarity-based stance that represents the ratio of positive and negative articles over all topic-related articles. We applied this method for the US President election 2016 to compare the stance with Trump and Clinton. For example, freerepublic.com contains more negative article for Clinton. We can confirm the existence of the bias using this simple framework. Even though this simple method can represent website's general stance, but it is not good enough for analyzing the news website from the viewpoint of its users' underlying interests. So, in this research, we would like to propose a framework to characterize news website stance considering topic instances. At the first step, we would like to use news genres as labels for topic classification. Since most of the news websites use such category, we made following 7 categories for classification: politics, domestic, international, economy, science, lifestyle, sports, and entertainment. Original polarity-based stance is represented as a 3-dimension vector using ratio of positive, neutral, and negative articles in the topic-related article. This vector is extended by using news genre. Since we have a 7 genre and 3 stance, positive, neutral, and negative, we have 3 by 7 matrix for representing news genre polarity-based stance. For visualizing such multidimensional data, we use multidimensional scaling, MDS. MDS is one of the well-known dimension reduction technique that tries to keep original distance in the final representation. As a result, we can find out similar objects using this framework. MDS can represent multidimensional data as 2-dimensional data, but the output may not fit users' interest. So, it is preferable to have a mechanism that can reflect users' interests on MDS results. Sirius is an interactive visualization tool based on MDS using symmetric duality of object and attribute. The system can update the MDS plot using weight for each dimension. This is an example of changing weight of attributes for calculating the distance. Based on this new instance information, new MDS results are generated. Sirius also have a mechanism to estimate the appropriate weight based on the interactive operation to the node location. For the news article database, we use GDELT, that is one of the largest news article repositories supported by Google. We pick up news websites that are listed in the media bias chart and use articles that mention Donald Trump for 2016 presidential campaign. For those websites, there are news websites that are already classified with news genres. For such websites, we use mapping rules of news genres. However, there are news sites that do not have such categories. We implement news genre classification system using BERT. Since GDELT data do not contain the contents, we use URL for genre estimation. Since most of the URLs contain title and genre information, we use URL as target data for news genre prediction. We conduct preliminary experiments on news genre prediction using URLs of the news article that can be classified by using mapping rules. We confirm the accuracy of the system is 87%, and it may be a good starting point for starting this research. By using news genre classification information and polarity value in the GDELT, we can calculate news genre polarity-based stance matrix. For the news sites, red color shows news sites classified as right wing, and blue one is for left wing. Due to the different interests on the topic, blue and red are not well separated in this MDS representation. This is an analysis example of estimating interest using node location operation. In order to show the similarity and dissimilarity of the news website, user can change the position of the news site. This example is for making a similar group among right wing and left wing with news sites. This operation is also represent the dissimilarity between right-wing news sites and left-wing news sites. This is a list of right and left-wing websites extracted from media bias chart. This is a result for estimating the importance of each dimension. Most of moved nodes are moved back towards original position, but the scattered plot seems to be more separated compared to the original one. The node size represents the importance of the dimensions of making the plot. From this result, ratio of negative articles in different topics are more important to classify the news sites. We also found that cluster of non-biased economic news sites at the left bottom. This may reflect the topic interests of the news sites still remain this MDS representation. We can also modify MDS representation by changing the weight for each dimension directly. This is an example that changes weight for positive, neutral, and negative of international dimensions. Based on this weight change, the system can show the similarity results focused on the international topic. News sites that have small number of articles for such a topic is gathered in the middle. On the contrary, news sites that have interests on international topics are highlighted. Foreignpolicy.com is a site that mostly introduces international articles, are located at here. And we can also discuss the similarity and dissimilarity of news sites for left-wing and right-wing news sites for international topics. For the summary, we propose an interactive method to analyze bias and topic interests of the news sites. Visualization of news sites with topic and bias can provide different kinds of aspects to analyze news sites. Attribute information may be helpful to understand the reason why the user assumes similarity and dissimilarity among news websites. However, further investigation is necessary to use this framework for more useful analysis. Thank you for the kind attention.
Yes, thank you. Are there any questions? Maybe we can get any questions if there are any questions. Okay, Masaharu, you are here.
Yeah, sure.
Are there any questions in the chat? No.
I couldn't find.
Okay, there is one question here in the room actually.
Yeah, thank you.
Would you like to come here and ask? Maybe it's easier. Yes. Thank you.
Hi. So you assume that positive articles and negative articles are some, let's say, good or bad attitude in news. But do you consider some approach that preparing negative articles about something, about some, I don't know, party or some event, is objective. It's not negative, but the objective approach. And the same one with positive. Positive is not only praising someone, but also it could be describing it objectively. Did you consider it?
Yeah, at this moment, we just try to think about more macroscopic analysis of the website. So that's the starting point of our research. So therefore, what we like to do is just for starting with given some particular topic and think about the positive and negative ratio is one of the starting point. However, yeah, as you mentioned, there are varieties of topics mostly biased to the negative or mostly biased to the positive and so on. So yeah, we would like to consider such kind of things. So that's the reason why we would like to introduce some multidimensional things into that. Some sites may be positive, tend to be positive for particular aspects, but not for some economic, positive to the domestic part, not for economic or something. So that's the reason why we would like to introduce this framework to extend such kind of things. So, but yeah, we also would like to think more concrete types of topics. Yeah, like yeah, for example, COVID is a vaccine or some isolation or lockdown. Those kind of topics is maybe also a candidate for that. So we would like to think such kind of things for the future research.
Okay, thanks.
Any other questions? Okay, then thank you very much, Masaharu.
Thank you.
And the next presentation will be information overload and user satisfaction, balance between reliance on recommendations and deliberate news selection. And it will be presented by Giselle.
Yes, can you see my screen now?
Yes.
That's great. So is this the presenter wheel or the full wheel?
It's the presenter mode we see right now.
Okay. Then I guess I'll go with this.
Yes, now we see the presentation.
Sounds good. Hello, everyone. My name is Giselle Pu. Today, I'm going to present a paper co-authored with Dr. Michael Beam. This is a user study about recommendations, information overload, and user satisfaction. Recommender system is regarded as a panacea for information overload, but what exactly in recommender system that have such impacts? That is a question that we are wondering and want to explore in this study. So we picked relevance as one of the key factors. And the next question we are exploring is whether such effect is true and valid for all of the conditions regardless of users' information behavior. That is to say, if people are seeking or scanning information, whether there will be any difference in the information overload. The third variable that we are interested in is users' news selection. When we design a recommender system, we always hope that the users can read and select the news that we promoted. So we picked the users' news selection as another variable that we explored in this study. We picked two factors in users' news selection. The first one is the number of irrelevant articles selected. It is an indicator of an effective system. And the next factor we select is the number of topic articles selected by users, which is a factor that is parallel to the top recommendations. Based on those background information, we proposed 4 models. The first 2 models are about the relationship between relevance and information overload and user satisfaction. The third and fourth models are about the relationships between information seeking, scanning, and information overload and user satisfaction. We designed an experiment. It is a 2x2 design. We manipulated the information behavior, either seeking or scanning, and relevance, either low or high relevance. We have 4 experimental conditions, and we picked 2 topics. Those 2 topics are selected from the 10 hot topics of Google search in 2017 and 2019. All of the materials are the actual Google search results. They are the first 2 pages results, and then we collected them and tailored them. For the manipulation, we have controlled seeking, scanning, and relevance. For the seeking condition, participants are required to type the keywords in the search bar and search for articles in the news portal. But for the scanning condition, they will not see the search bar. All they see is the instructions of those news, and then they will be asked to scan articles. For the relevance condition, we controlled 2 factors. The first is about the overall relevance, and the second is about the top 3 relevance. So for the high relevance condition, we promoted 16 relevant articles, and then all of the top 3 articles are relevant ones. But for the low relevance condition, we only give them 10 relevant articles, and only 1 among the top 3 articles is relevant. Here's a procedure. We recruited participants from ACM Turk, and they will sign the consent form in Qualtrics first. Then they were randomly assigned to one of the 8 web portals. We have 4 experimental conditions and 2 topics. That's why we have 8 web portals. On the first page of the web portal, it is a welcome page. It instructs people either to seek or scan information. For people who scan information, that's where they see the search bar. But for the scans group, they only see the instruction there. The second page of the website is the instruction about how to read news and how to navigate the web portal. The third page is about the news page. We displayed 20 articles there. We displayed the headline and the first 100 characters of each article. The articles were randomly selected from a database, and then they were randomly ranked. Each participant will need to read 3 articles. And we also designed 4 pop-ups reminding people how many articles they have read and how many articles they still need to read. After reading the 3rd article, they will see the go to the survey button at the bottom of the 3rd article. And then they will go to the Qualtrics and finish a survey. We recruited 834 participants on ACM Turk, which is far more than the suggested sample size in G-Power. And we also cleaned data. The final data sets contained 2 portions of data. The digital trace data, including the conditions people are in, either they are seeking or scanning, or either they are in the high or low relevance condition. We also recorded the order of article and the article selected by users and the reading time of each article. We also have the survey data that is collected in Qualtrics. After data cleaning, we have 669 participants. The majority of them were females and the majority of them were white people. We did a manipulation check to see whether our conditions work, and it turns out that the conditions works pretty well. I have also listed our measurements here. We adopted the existing scales from different research, and the Cranberries alpha is pretty high, and all of them are acceptable. If you're interested in those measurements, I have some details after this presentation. I'd be happy to talk about them. For the data analysis, we used a highest process model. It is a regression-based model to test the mediation effects. So here are the results. The first 2 models are about the relationship between relevance and information overload. For this part, we manipulated relevance by giving them either a greater or lower proportion of the relevant articles. So here we can find a simple mediation model here for people who are exposed to a greater proportion of relevant articles. They will select fewer irrelevant articles, and then they receive less information overload and higher user satisfaction. And we also find the direct effects from relevance to information overload and user satisfaction, not user satisfaction, just information overload. That is to say, people who are exposed to more relevant articles are less likely to experience information overload, both directly and indirectly. We also find that people who are in the high relevance condition are more likely to select more top articles. And it is also true for model 2. Though we didn't find the direct effects between relevance and user satisfaction, but we find that relevance still impacts user satisfaction indirectly. So for the high relevance condition, people will experience higher user satisfaction indirectly. For the model 3 and model 4, we manipulated information behavior. For the seeking group, they will type in the keywords in the search bar, but for the scanning group, they will only scan information. With this part is pretty surprising because we propose that there should be some relationship between information seeking, scanning, and goal commitment. But it is not that there's no relationship there. However, we still find the simple mediation model there. We find that people who have higher level of goal commitment will read fewer irrelevant articles and experience less information overload and higher user satisfaction. On the other hand, people who have higher goal commitment have experienced information overload, lower information overload directly, and higher user satisfaction directly. So for the discussion portion, I would like to give you a brief general discussion about the general portion, including content relevance and seeking scanning. So first, we find that content relevance did impact the outcome variables. However, we did not find any impacts about seeking scanning might impact goal commitment. We did find goal commitment impacts users' new selection and outcome variables. And the next step is that I will introduce some detailed findings there. Regarding the content relevance, we find that users who read fewer irrelevant articles when being exposed to a greater proportion of highly relevant recommendations. That means recommendations do influence users' new selection. What users see are what they can select from. And then we also find that when users are exposed to more irrelevant articles, they will also select more irrelevant articles. That is inevitable. So two reasons can explain that. The first is that people might experience choice overload when there are so many similar articles, and then users might be hesitant to read or to select the articles there. And they may have some reliance on news recommendations based on the peripheral rule of the dual process theories in cognitive processing. They find that users tend to limit their cognitive effort. So if they can rely on news recommendations, and they tend to do that, they will not want to select news by themselves. The other finding is that users who are exposed to a greater proportion of highly relevant articles are more likely to select more top articles. It can indicate the trust towards recommendations, or people experience cognitive load and they don't want to read more, they just want to see what's there. Next finding is that people read more irrelevant articles, and then they will experience higher information overload and fewer user satisfaction. They will have some doubt about their ability to seek or scan information, and there are some frustrations towards the recommendations. And the last finding is about homogeneous content. So we might want to consider that when we recommend a lot of similar content, especially in search engines, when we promote those contents based on the keywords, and there will be a lot of similar content. Then how can we help users navigate those environments and help them select the content that is appropriate and relevant to them? So when all the articles are relevant, which one should they select from? And regarding the findings of scanning and seeking, we find that when users begin to select news deliberately and take control, they are less likely to experience information overload, and that leads to higher user satisfaction. So here are some contributions. We provide the empirical evidence showing that relevance impacts information overload and user satisfaction, and we find that goal commitment have impact the corresponding outcomes as well. We want to provide some practical guidance to users. So if you have a higher goal commitment and agency, you probably will have a more satisfied online information experience. And we also want to provide some design principles that we need to consider user agency, and the other principle is that top recommendations do not always lead to higher user satisfaction. And there are some limitations there. We recommend that future research look at the goal commitment and to manipulate goal commitment. Also, we recommend the future research to look at more relevance instead of the content relevance. There are so many types of relevance there. And the future research could also look at the other types of filtering rules instead of the content filtering. We also suggest the future research to look at more about when seeking and scanning can make a difference in the outcome variables, and whether there are some more users' new selection measures that we can study. The major takeaways here is that relevance is still the key factor. So we should be pretty cautious about what we recommend to users. And the other thing is user control is also very important. So we might want to take that into consideration and give users some control to ensure a better user experience in the web portal or the search engines or the other type of recommended systems. Also, individual differences such as goal commitment also matters. And the last takeaway is that the balance between reliance on recommendations and deliberate new selection is important, and we need to consider that. Those are all our presentation. We are pretty happy to talk more about this study, and we will take questions. So feel free to reach out and feel free to ask questions.
Thank you, Giselle. Thanks for the presentation. So there is one question in the chat, I guess. If you can have a look at it, I will try to read it maybe here as well. Did you also show pictures of the article, or did you only show the text? Would images have an influence on the results?
Yeah, that's a good question. So we only show the text here, and I have another study show the image, and we do have the similar concerns that if we show the images, whether there will be some impacts there. So for this study, we only show the text, and I can show you the example of the web portals to give you a sense of what experience there is. So this is the first page for the scanning group. This is the first page, and they only see the instructions and go to the next page. But for the this one is for the scanning group, and for the seeking group, they have a search bar, and they have to tap in something to go to the next page. And then this is a first pop-up. We show people that how many articles they have selected. And then we have show the second pop-up about they selected the second article. We also find the third articles. And here's the go to the survey button. And we also have the high relevant condition. Those are the three top articles. Those are all the relevant ones. And for the low relevance condition, you can see only the fatigue one is the relevant article, and all the others are the irrelevant ones.
Okay, thank you. There is one question here in the room. Would you mind coming here and asking your question? Giselle can also see you.
Yeah, thank you, Giselle. I was wondering, did you also vary the relevance within a list? Because I think that choice overload often happens is that it's a bit difficult to choose between items, and that I think, for example, the work of Dirk Bollen in 2010 showed that if you just add, let's say, from a top-end list, the 100 and the 200 item, then you can reduce choice overload because you can sort of differentiate between these items. Was this more like an all or nothing reduction in relevance, or how did you do that?
Yeah, thanks, Elaine. That's a good question. Yeah, we showed 20 articles on the news page, and then we retrieved those articles from the first 2 pages of the Google search. So that means all of those relevant articles are super relevant and super similar to each other.
Okay, and then so was there, if you would have, let's say, low relevance, would then the relevance difference between the news articles still be similar to the difference in the high relevance condition, if you understand what I mean?
Yeah, yeah. For the relevant articles, they are still the same ones from the same, like they are the ones in the same data set, and we select them and they are super similar to each other. But in the low relevance condition, we provided more irrelevant articles. That is totally irrelevant to the topic.
Okay, yeah. Okay, thanks.
Okay, I don't see any questions in the room. And I don't see any questions in the chat, so thank you. Thanks for your presentation, Giselle. Okay, so we don't have a break before the next session. So the next session is the interactive session. So we actually would like you, the participants here and online, we would like you to introduce, if you have any upcoming events related to news recommender systems, like seminars, conferences, challenges, or if you have any ongoing projects that you would like to introduce to us, or if you have any project ideas, we would like to hear about them. Also, I believe Benjamin has a few slides to show. So while he's showing those slides, maybe you can think about if there is anything that you would like to tell us today. Okay.
Yeah, I'm not sure how many of you are familiar with Media Eval, so I thought I'd introduce it quickly. It's an ongoing multimedia evaluation benchmark. I think, if I'm not mistaken, we had the 10th edition last year or the year before, so it has a quite long tradition now. This year, it features 3 tasks that are actually related to news. So one task, emerging news, is essentially trying to detect emerging news stories, which is related to this workshop. Then we have one task that's related to fake news detection. And the task that I want to talk about is the task that Özlem, Andreas, and I co-organize with a few others, which is called News Images. Before I come to the details of the task, I would like to give you a short sketch of what Media Eval actually involves for the participants. So essentially at the beginning, we release a task description. This usually happens in the springtime or late spring. Then we release a data set. This has already happened this year. Then the participants work on a solution. They usually have a couple of months' time to come up with something. They describe their results and observations in a working note, and the working note is then presented in the workshop session, which will take place this year in December, and it will be a virtual event. We were hoping that we could have it in person in Bergen in Norway, but yeah, we decided it's probably easier for everyone to attend the online event. The deadline for submitting a solution is November 2021. So as you see, you still have time. We have September now, so you can still work on it, and I would encourage you to do. And on the right-hand side, you see the website. The link is also on the slide, but I think it's just a bit obscured at the moment, but I will tweet it later so you can find it. What our task News Images is about is essentially twofold. The first task that we defined is we took a large collection of news articles that also had some images attached, and we just removed the link between them. So you get essentially one list with texts and one list with images. And the task is then to find out a good way to recombine them. The dataset is rather large, I would say, so it covers, the training data covers 3 months, and the evaluation set is then 1 month. You have to download the pictures yourself because we don't have the copyright, but that should not be too much of an obstacle. And the second subtask is a click prediction. In this set, we have the link still there, so you get essentially one big file with images and articles, and we want you essentially to predict how many clicks do the individual articles get. And then we will compute some form of precision, seeing if you can identify the most likely click targets for the users. As you recall, the task requires you to submit a prediction by November this year, so 1 month is still left. If you're interested in this, please come and talk to me. I will be on the conference until Friday, so there should be plenty of time. And if you have questions, yeah, you can also get in touch with me virtually on Twitter or on email. Okay, and you can get a nice pen with Mediaeval on it if you want. We have a few. I think we're not that many in the room. So sorry for the virtual attendees, you don't get a pen, but the ones that are here physically can get one. Okay, any questions directly? Or I don't see any, so we can continue with other announcements. I think Özlem has also some announcement to make, more related to a special issue about news personalization and analytics.
Yes. Thank you. I already actually mentioned it in the introduction session. So let me see if I can find the link. Okay, yeah, I don't know where the link is right now, but yeah, I think I mentioned, so we have a special issue coming up that will be in the user modeling and user adapted interaction journal. So we proposed to publish a special issue within this journal, and then it's recently accepted, so we don't have any set deadlines, but I think we are quite flexible about them. And we also have a web page that is activated last night, so I couldn't find the link, but there was a screenshot in my introductory slides. Maybe I can show it there once more. So if you are, yeah, we would like to welcome you to submit your work to the special issue. Yes, the link is also here. And we will share it further, of course. So we have some preliminary important dates, but they are not set yet. So we have to we haven't really discussed and gave it the last set the last deadlines. So these are news from us. We have 2 things going on, and also next year it will be the 10th edition of this workshop. We would like to also organize the 10th edition, maybe something special for the 10th year anniversary. And you are welcome to join us if you are interested. Please let us know, show your interest, so we can maybe collaborate on that. Okay, so if anyone has anything to announce, any events, anything upcoming, any projects, interesting projects going on maybe, or any project ideas, also online participants are welcome to talk us. Yes, please. Yes. Would you like to connect your computer? Yes.
I actually need an adapter for the Mac. Thank you. So we actually have a demo, and the whole idea that we are doing here, at least for the presentation and the demo that was accepted, is that you know that the audiences from publishers are very diverse, right? But the newsletter that are sent is sent exactly the same newsletter to everyone, which doesn't make too much sense. So what we are doing is to personalize newsletters. So this is a tool for publishers. So we empower them to segment their audience automatically and then select articles that are sent to each of the cohorts that are identified. This is our tool, and we have a poster downstairs, and then I can also show you briefly how it goes. So I mean, this is the pipeline, but I won't go over it. I would rather perhaps show you how the tool looks like. So this is centered from different sources, and it's around migration in the US mostly. So what we have is keywords that will define if you have a specific segment in mind, or directly discover so different segments that are identifying the data. So sorry, this is running. This has several articles. So the whole point here is that this one could become already defined newsletters for the publisher, where you have different rankings, of course, depending on the cohort that is identified. And what we are looking is to publishers to validate this and to use this tool more, right? I mean, we have some pilot partners, at least in the project, right? But it would be welcome if you are interested to use it or to connect with publishers. Just let me know. So I'll have the demo there, and we can go in detail more on this. So thank you. Thank you. It's not needed. It's like, thank you.
Okay, is there anyone from the online participants who would like to talk about upcoming ideas or ongoing projects?
Yeah, I have an announcement. Can you hear me?
We hear you a little bit.
How about now?
Yes, I think now it's better.
Okay. Next year, all the INRA organizers and Dr. Michael Bean will propose a panel at the International Communication Society Association. We will discuss the research updates on the news recommender systems. So it's up to what happened in the 2021 and 2022, and then we will have some updates on that, and we will have a panel discussion about what's going on and the new fundings and the new challenges in the field. So the purpose of that panel is to discuss some fundings with the scholars in different disciplines, including computer science and communication science or some other disciplines. So if you are interested in that and you want to get engaged in the panel discussion, just email me and let me know, and then we can discuss further. Thank you.
Thanks, Giselle. I didn't quite catch in which venue are you planning the panel? Can you maybe write it in the chat so people can see it written?
Sure.
Okay, thank you. Okay, anyone else? Okay, if not, I guess it's time for some mingling and some break before the lunch in here. And for the online participants, I think it's a good idea to have another Wonder Me session. So you can also mingle digitally. So thank you everyone for coming today, for participating. I think it was great talks and great presentations. Okay, see you around then.
Thanks everyone for not doing the very important.